Hey, and welcome to a new tutorial. In this one, I'm going to be talking about the action system, which is a system in this toolkit which is used to separate game logic from what is shown to the player. So while game logic happens instantly, so for instance, the moment I let go of this, damage will be dealt to the status component of this minion, but you will see that it happens a bit later visually to the player. We are first waiting for this animation and for the flinch animation, etc., before we actually see it. So there's a delay between when the game logic is actually happening and what we are showing. So I can illustrate this better if I slow things down here a bit. So let's go to the, let's see, first the minions here, the monsters. And for the troll, I'm going to reduce their health so that we can kill one of these in 2 hits, I'll get to why this will illustrate the point. And then in demo, we'll find in characters our warrior and find his animation blueprint. And then in the event graph, we'll reduce the animation speed of this guy, of montages, to 1/10. So we can see more clearly the separation here between game logic and animation. So yeah, now we have a really slow motion entrance, very dramatic. Well, the trolls should be popping down in the regular speed. Yeah, there they go. So you should see now that so what I'm going to do is to try to kill this, or to use 3 attack cards on this troll. And remember, the game logic applies this damage instantly. This means that I will not be able to use the 3rd smite attack, because as he only has 10 health and my smites do 9 damage, there will be no valid target. So I will do this quickly, like this, and then another one, and I'll try to target him with the 3rd one, and you see that I can't because he is already dead, while I can target this other guy. So in this way, the actions are playing out at a later time than the actual game logic, and this can be practical in that it will allow you to, the player to use cards one after another quickly and not have to wait for animations to play out. It's also useful for making many kinds of more advanced game logic where you need to know the states things are in or are going to be in instantly beforehand. This is used in a number of different games. Anyone has played Hearthstone, you can see the same thing there. If you do some sort of complicated random effect from a card, and if you use it and it will end up killing one of the players, you're going to see that the end turn button gets grayed out because you can't end the turn because the game has ended. So you can instantly see that the card is going to result in one of the players dying, but then you're waiting to see the animation play out before you can actually see the result. So this is a common way of splitting up game logic and animation. Another benefit of this is that splitting it off in this way makes it easier to swap out any visuals with the visuals you would prefer, since the game logic is not tied to what is actually moving here. So the puppets, they are just here to which these are called, they're just here to represent the minion, but they are not responsible for any of the game logic for the minion itself. Similarly, the cards, the game logic is in BP card, a blueprint actor which is invisible, but you are interacting with the card through this widget, which is only responsible for visualizing it to the player and also allowing the player to provide input. So that's the general idea. For those of you who's used one of my other assets, the Advanced Turn-Based Tile Toolkit, you'll recognize the system as it works essentially the same. It's a bit simpler here since you don't have to do any networking, which complicates it quite a bit, but it is the same general idea. So I'm going to explain also a bit more how it works, but we'll do that using an example, which should make it easier to grok. Hopefully. So you can think of actions kind of like functions, actually. I mean, you call them to do something, but the difference is, functions, they happen instantly, while actions, you tell it to do something, and then it might be some delay and it plays some animation, and then the action itself tells then the action manager, which is the blueprint responsible here in core, the action manager RLDB for managing the order and sequence of actions. But actions are actors, so they can be spawned, and when they are spawned, they are automatically added to the action queue. That means that they're going to spawn, they're going to play out after all of the previously spawned actions are done playing. So we can create an example action here. So I'm thinking of, so we're creating a new one from scratch, and we're basing it then off, oh, not just actor, we're basing it off the action RLDB here, which is the parent action. And we'll switch this name to BP action enlarge. What I have in mind here is that we add an action which causes a minion to enlarge in size. And I'm thinking of just adding this to the regular like strength increase status that we have, the strength status. So every time we increase in strength, we also increase the size of the minion. That way we don't have to make any custom new status or card for this tutorial, since the focus is going to be on actions. But let's open this action up and see how it works. So we start with a blank canvas here, and to set up the essentially function responsible for playing out this action, it is an event. Then you need the event play action. So this is what is called by the action manager when it is this time for the action in the queue to be played. So within this we can do whatever we want to animate, and then after this we have to call end action, which will signal to the action manager that we're done with this action and we want to proceed to the next one. So everything that we want to animate we are going to do within or between these two. So you always need to call this, you always need to call this for an action to work. So for this we want to enlarge the puppet that is gaining strength. So we will need to input the puppet that we want to enlarge. So similarly to how you would add, inputs to a function, instead of that you're adding variables to the action. So we can add a new one. We can call it puppet to enlarge, and it should be an actor because a puppet can be any type of actor. And we need to set this variable as instance editable and expose on spawn, so that we can use this essentially as an input when we are spawning this action. And now we have access to the puppet, so we can enlarge it. So of course we will have to pass the correct puppet into this this action, which we will do later. And so we'll start with the simplest way possible. We're just setting the scale of this directly, or scale. Let's see, set actor scale, and we can just get the current scale. And let's just multiply this by a value, so we can so it should be we can also set the amount we are going to increase the size to a variable as well. So we can promote this and then call this size scale, also instance editable, exposed to spawn, and we can set its default to, let's say, 1.2. And then we are ending the action. So then it will continue to the next action. So now we need to call this from somewhere. And like I said, we can do this within our strength status. So if we go to our statuses and find the strength status, we can see here is how the strength status is set up. This is the function for adding a status value. So this is also the point in which we can queue our action. So then we spawn an actor, and we spawn then our enlarge action. And we can just connect this up. I won't make it too pretty for this. We don't need to line it up, and you need to also split here, like you saw that I did. Split the spawn transform to be able to compile this. The location of the action doesn't matter. but you need to split this to not get an error when compiling. And then we keep the size scale here, and we need to find a puppet. So then we can just get the owner of this strength status, since we know that it's going to be a minion. Though the minion itself is an invisible actor, we will need to access the puppet of that minion. But I know that the puppet actor implements this interface, so we can get the puppet through this interface function and pass this into our action like this. So now when we use our any effect that gives a strength status, then we should enlarge the minion that owns that status. And we can test that out by going to our, let's see, our card data. Yeah, we actually don't need to do that. We can just go to our decks. And in our starter deck, I'm going to change the first smite here to Boar's Strength, which is a card which gives strength. And yeah, it's set up like this already here, but probably not in your project. If you go to the pile component hand, you can set random draw order to false, so that we know we're going to draw this card first, which is useful for testing. So now we can test this out, and yeah, we're still going in super slow-mo, but we can wait for that. That will make it easier still to see the sequence in which things happen. So then we use Boar's Strength, and now the cast animation starts, and on top of this he resizes, and then you saw also the strength splash effect that appeared. So the resize happened at the correct moment. For this, I'm not really making use of actions to their strongest potential, though. We are still doing something that happened instantly, right? So you will, even though if you have something that happens instantly, you will want to add it to the queue. I can show what happens if we did not add it to the queue. So let's go back to our let's see, the strength status here. So instead of spawning this action, let's say I just set the scale of this puppet directly. So I set the actor scale here to 1.2 across the board, and I do that instead of spawning the action. If I do this and we hit play and we wait for the slow descent, what you're going to see is that instead of waiting for this cast animation to happen, which happens within an action, he will resize instantly and then the cast animation happens. So since it happens before all of this stuff, it's not in the action queue, and therefore it happens instantly. And therefore we're using actions instead. But we can add some delayed functionality within the action to show that as well. So since we are in an event graph here and not within a function, we can actually use a timeline to animate our resizing here. So let's just call this TL enlarge, and I'll go to this and I'll just add a couple of points. I'll put the length down to 1, this one to 0, 0, and at the end point we'll have a time point 1 will be resized to 1.2. We'll just ignore the input for this one. We'll just hard code it in here, but of course you could have this be 0 to 1 and then multiply that by some scale factor or something. Yeah, let's just rename this as well to enlarge. But just to simply show how this works, we can then on the update set the actor scale. So instead of setting it to this, we are setting it to the output of our timeline here, and then we end our action when our timeline is done. So if we play this now, we should have a 1 second animation that shows this guy gradually resizing. So let's see that. So first the cast animation, then we get the, whoops, okay, something's wrong here. Let's see what happened. Oh yeah, did I put it from 0? I did. Okay, so 1 to 1.2. That makes more sense. Maybe I should really speed up this here. But yeah, still useful to see the ordering, right? Okay, so cast animation, resize. Whoops. Okay, I'm learning a lot from this. Okay, well, okay, it makes sense because I'm getting the current scale and I'm multiplying it all the time. So this is increasing along with this, of course. So we need to like cache this beforehand, so we can get the actor scale, promote this to like the puppet pre-scale. And then we're basing the new scale layer on the puppet pre-scale instead of its current scale. Let's also make it a bit more organized. Can't help myself. Okay, now third time's the charm, right? And you know, let's put this play rate just a bit faster. So still slow enough to see what's going on. And then cast animation, resize finally, and then we get the strength, you know, splash effect. And you can see that this splash that happens here, that's also actually an action. So if we go to the strength status and we look into the add status value parent function here, you can see that we are spawning this this modify status action, which you can see as a planned improvement that I think is overly complex at the moment. So it might be simpler when you're looking at this after a future improvement, but the same idea will probably stand, that I'm spawning this action for animating what the action or what this status is doing, like showing this splash and showing the text for the amount of strength you're getting, etc. It happens here. So this means that if we go here and we put this on the other side of this, so we do this that is in the parent first, and then we do the resizing. What we should see is that first we get that, you know, it shows that we're getting a strength effect, and then the resize happens afterwards. So we can see that now. And then we first get, you know, strength, and then we resize. So the order in which you spawn actions determines the order in which they are going to be played. So that's most of the important stuff, but there's one more thing that I should cover, and that's how the action system interacts with the event dispatcher system. So for this last part, you should have seen already the event dispatcher tutorial that I have also on in the playlist. So if we go and look at all of our events, which are in data and tags, we have the event tags. You can see that some of these are marked as action, that they are event action active discard, for instance, or action win game. So these are just the same as any other gameplay tag, really, any other event, any other gameplay tag. It's just that I'm marking these to make it clear that these ones are meant to be used with the action system. So to give one example of where I use this, you can take when you discard a card, for instance. So if we look at the hand component, which is responsible for discarding cards from itself, resolve discard is the function we want to look at. You see that here, that when resolving a discard, well, first it's checking, you know, that we actually have the card in hand that we want to discard, and after that you instantly transfer this card to another pile, which means that the reference to this card is then moved from the array of cards we have in the hand pile, and it is transferred to the array of cards that is in the discard pile. So this happens immediately, but we want to show the discard happening, right? So therefore I'm also then queuing an event in the global dispatcher hub. And then I am queuing the event action discard event. And we'll take a look at this and see how this works. This is within, well, first we go into the singletons and a function library here. This is so that we can access this from anywhere. We are getting the global dispatcher hub, and we're calling the queue event function here. And all it does is, so this should be recognizable, that it's spawning an action. So the action dispatcher event. And this is a very simple action. And all it does is, if we look here, is to call bound events, which you can recall from the event dispatcher tutorial. This is how it calls out to any actors that might be bound up to that specific event tag that something is supposed to happen. But since this happens within an action, it happens on the queue. So that means that if you queue an action, say after this enlarge animation has played out, then that event is not going to be called until after the enlarge is finished. And going back to the hand component then, so this is what happens with this action discard. To look at this in play, so really the moment we let go of this block card, it is added to the discard pile. But you see that we have this second and a bit more because of the slowdown animation before it shows itself being transferred. And this is done in the hand widget. Got a lot of tabs open now, but not that much more left of the tutorial, so I'll keep it like this. So in the card hand, you can see that the card hand subscribes to a whole bunch of different events. A lot of them are actions. And on the run event, you can see that on discard, the action discard, it is telling that particular card widget to animate itself. So this is a way in which the event system and the action system can interact with each other. So that's one of the more complex topics that is combining two of the custom systems in this toolkit together. But if you learn how to use both of those in tandem, it will give you a lot of power about controlling the sequence in which things are animated, etc. So I imagine this video and these topics in particular might be some of the more difficult to grasp of the ones I've discussed, also because there's some of the more unique ones to this toolkit. So I understand it fully if someone needs more help on this. So please feel free to ask me in the support thread or on Discord. And also if you have any ideas to additional tutorials or something I can make on this to make things clearer when I hear from you guys which part of these this is more difficult to grasp. But once you learn how to use both of these, it becomes really fun and easy to just add some new actions and then have them queued up, and then you can just fire those and forget essentially, and you don't need to do anything like each time you make a call to one specific actor and then you have to remember to every time bind to some other event. So when it's done, you are returning to some other event and so on. So this, even though it's a bit to learn up front, this makes it a lot easier to code down the line. There's one more important thing I should mention, by the way, about these actions, and that is they are intended for visual stuff only. So you shouldn't be doing gameplay logic code in it. And I mean, I can illustrate this again in this example here. So if we do this stuff with showing these animations, then you don't want to actually be dealing damage to the health component within the action, because that might be happening after the minion has actually been destroyed. So by the point this animation has stopped playing and we are at the part of the action where we want to show the damage, there is no longer, the reference to the minion is gone because it has been destroyed, right? So all of the actions, they happen asynchronously to the actual gameplay logic. Therefore, you want to keep all the gameplay logic apart from the action, and you want to just do visual stuff within the action itself. There are some small kind of exceptions to this if you want to use it like some sort of quasi delay or wait for player input, but like in a very generally you don't want to do any gameplay logic stuff within action. So keep those two things separate and you'll have a much easier time. Okay, so that is all I have to say about actions this time around. I hope it was informative, and I guess I'll see you in the next video.